Algebra 2, Lesson 105, Advanced Factoring. So this should be a pretty quick lesson because we're building off of trinomial factoring, which we already know. And then advanced factoring is going to be factoring trinomials like this into a set of parentheses. It's only slightly different though, because you'll notice normally when we have a lead coefficient of x squared, whether it be another x, a letter, or a coefficient, numeral like 2, we want to factor that out as a greatest common factor, right? Now if you look at all these numbers, 2 cannot become the greatest common factor because 7 can't be divided by 2, neither can 15. Now normally we would just jump straight into quadratic formula, but when your problem tells you to use advanced factoring, you know that you can then split it up and you can factor the 2 into the beginning. So we're going to keep using trinomial factoring like this. We don't have to use quadratic formula because they told us we can use advanced factoring. But the question is, what do I do with this 2? So if you think about FOIL and how when you're multiplying FOIL, the first number times the first number will always equal the first number, you ask yourself what times what will equal 2x squared. And in this case, it does not have to be the same number anymore because we know there's no perfect square root to 2. So if you ask that question, what times what will equal 2x squared, well then one number is just going to be x, right? And then the other number is going to have the coefficient of 2. So x times 2x equals 2x squared. And this is where the advanced part comes in. Once we get that first part, we have to start thinking a little bit harder. So normally we would go ahead and put in our symbols. We would look at the last sign, say that's a negative. Okay, one's positive, one's negative. Now on advanced trinomial factoring, I'm not going to put my plus or minus signs in yet. And the reason why is because of this 2. This 2 means that the plus is either on the left or the right side. If I put the plus on the left side when it should be on the right side, I can make the entire problem wrong. So I can no longer just put the plus and minus signs in without knowing any more information. I have to know exactly where they go because the 2 changes things. We no longer have the same quantity. We have 2 different quantities. So the location of the signs matters. So no worry, we're just going to skip that step for now, and then we go to the last step, which is factoring the number 15. So if I factor the number 15, I have 1 times 15, and then I get 3 times 5, and that's really it. So now I ask myself, which one of these numbers, 1 and 15, and 3 and 5, will add up to negative 7? The answer is none of them will. So we have to start thinking about this 2 and the negative, okay? So we know that there's going to be a plus and a minus, and what this 2 does is this 2, when it multiplies by the other number, it's going to double that number. So when you start looking at these factors, think about if you double one of the numbers, could you get the number 7? So if I look at 1 and 15, if I double the number 1, would 2 and 15 add or subtract to 7? Well, I could get 17 and 13, but I'd never get 7. So that means it's got to be 3 and 5. So let's look at 3 and 5. If I double the 3, will 6 and 5 ever add or subtract to negative 7? I can get 11 and I can get negative 1, but I cannot get 7. So then I'll try the 5. If I double the 5, will 3 and 10 ever end up as 7? They will. And it would have to be the negative 5. So what I do here is once I realize that, I take the 5, I make it a negative, and I put it away from the 2. It cannot be in the same spot as the 2 because it has to get multiplied by the 2. Then I know that the last sign is positive 3. So that's advanced trinomial factoring. Now I also have to remember this is an equation. So this all equals 0. Now the first version is pretty easy. I can use zero factor theorem and I can see that x minus 5 means that one of the possible answers is positive 5 because I have to use the opposite sign. If I make x 5, then 5 minus 5 would equal 0. 0 times any number would equal 0. So zero factor theorem can work here. This one can be a little bit more tricky. 2x plus 3. Now what 2x plus 3 does, there's 2 ways to go about this. The first way is I could write it as an equation and then solve the equation. So when you come up upon a parentheses in zero factor theorem where there's a coefficient on the variable, you can just take that parentheses and write its own equation. 2x plus 3 equals 0. And if you solve this equation for x, that'll give you the value that you need. So if I subtract 3 from each side, and then I get 2x equals negative 3, then I can divide by 2, and negative 3/2 is the answer. So my options are 5 or negative 3 halves. Now, the other option that is also very quick, and this is a great way to solve these quickly, just remember, normally since we would just look at this number, we'd use the opposite of this number, right? So if that 2 wasn't there, we would just have -3, right? In advanced trinomial factoring, you can always take this number, the 3, grab its opposite, -3, and then divide it by the coefficient of x, and that's your answer. And we can see that right here. If I were just to look here and say, okay, that's -3, and then divide it by the 2, that's my answer, -3/2. Okay, and I'll do that example on the next problem. But these are our answers right here for this first problem. The answers are 5 or -3/2. And then I'll show you the faster way to get this number instead of solving the equation on the second example. So let's go ahead and get started on that. First thing I notice on the second example is it's not in descending order. It's also not equal to 0, so I got to make some changes. I'll go ahead and add 6x squared to both sides. That will set it equal to 0, and then I can write it in descending order, 6x squared minus 5x minus 6. From here, I go ahead and begin my advanced trinomial factoring. I'm going to have x and 6x. Then I factor -6. So I'm going to have, let's see here, we've got 1 and 6, and then 2 and 3, and that's it. So then 6 times which one of these numbers will give us -5 for an answer. So if I do 6 times 2, that's 12. 12 and 3 will never add up to 5. I could get 9 or 15, but that doesn't work. Let's see here, 6 times 3 would give me 18. 18 and 2 would be 20 or 16, so that doesn't work either. Let's try 6 and 6. Let's see here, 6 and 6 is 36. 36 and 1, that's not going to work either. Wait, did I write this problem down correctly? I feel like this one is a little bit off. Nope, nope, I did it right. Okay. Wait. Yep. Okay. All right. How am I going to get -5? If I do 6 times 6, 6 and 6 would just add up to 0. This is a toughie. Hold on. I think I might have messed something up. Let me double check the example, make sure I wrote this down correctly. Oh, no, okay. I did write it down correctly. I forgot something. Okay, so here we're at an impasse. I'm looking at the 6x and the x, and then I see that if I do any one of these, I'll never add up to -5, right? There's another option for when you have composite coefficients to the lead term. Is 6x times x the only way to get 6x squared? No. There's another way that I didn't think about until just now when I looked at it. So if you have a number that's not a prime number like 2 was in this example, so we've got a composite number 6, meaning that 6 has factorable numbers, then there's 2 options for this. I just tried the first option, which is 1 and 6. That one didn't work. So it has to be 2x and 3x. So this one did not work. This one has to be the correct one. So then I go back to my factorings. Now I have to multiply both of them. Where can I use 2 and 3 to multiply by these numbers to get a -5? So if I take 2 times 2, that gives me 4. 3 times 3 gives me 9. Will 9 and 4 add up to -5? Yes, they will. Okay, so if 3 has to be times 3, then that means the 3 is going to be away from there. If 2 has to be times 2, then the 2 has to be over here. Now the question is positive and negative. 3 times 3 is 9, and it has to be a -9, so that way we can add up to +4. So that's how we get our symbols. All right, so now that we've gotten that out of the way, and this one takes a little bit more mental hurdles to do the addition quickly in your head, so if you're having trouble with that, let me know. So once we've done all that, we can go ahead and get our x answers very quickly. So if you remember what I said, we take this number and we do the opposite of that. So instead of -3, I'm going to have +3. And then to figure out the x value, I just divide it by 2. So one answer is 3/2. Or here, instead of taking 2, I'm going to take -2, and then I'm going to divide it by 3. Or -2/3. And those are our correct answers. And that method is much faster than doing the solve the equation method. Whichever one works for you, though, is the one that you should go with. Also, be wary of composite coefficients on your x squared terms. And that's it for this lesson. So if you guys have any questions, let me know in class. And have a good day, weekend, month, year, summer. All right.